Okay, this is another video. My name is George Montoya. So the question over here, this is statistics having to do with confidence intervals. So now the question is, a nurse practitioner working in the dermatology clinic is studying the efficacy of tretilinine in treating women's postpartum abdominal stretch marks from a sample of 15 women. The mean reduction of stretch mark score is negative 0.33 with a sample standard deviation of 2.46. Describe what happens to the confidence interval if analyses are conducted on a progressively larger sample. Example 30, 50, 100 participants. Show your confidence interval calculation for the samples of 30, 50, and 100. So, okay, so over here we could see that we're dealing with a very small number of women. So our sample size is very small, only 15. And from there, we get this number, negative 0.33. Now, if this is only for 15, and we're looking at a whole population, this probably is not enough of a sample. And we do get a standard deviation, but again, this is only based on 15. So now we would think that as we get more and more participants participating in a sample, we would get a better value. And in this case, the value that we're looking for is the mean reduction of stretch marks. Okay, so if we go to this formula, which is our general confidence interval, it tells you that the confidence interval is equal to your mean value plus and minus a z-value divided by your sample standard deviation divided by the square root of the sample size. Again, let me say that. The confidence interval is equal to x bar, which is our mean, plus and minus our z-value, that's depending on your confidence interval, multiplied by the sample standard deviation divided by the square root of n. So I'm not sure if you know what happens over here, but as n increases in value, then this number, this whole number, is going to get smaller. So it means that as we get more and more of a larger sample size, basically what's going to happen is that this number right here is going to shrink in size. Okay, so let's take a look at what happens. So right now I know that my n is equal to 15. My x bar is equal to 0.33. And my sample standard deviation is equal to 2.46. Now we want to explain what happens to the confidence interval as the sample size gets bigger. So we want to do 30, 50, 100, also 15. Okay, so now this is an open-ended question. Not all the information that you need is given, so we're going to have to make some assumptions. Okay, we will first use the confidence interval of 95. So we're going to use a confidence interval of 95. Okay, so we're going to use a z-value for 95. Again, you could get this either from a table, information that's given to you. You could use some sort of technology, but you will be getting this. Actually, there really will be another video on how to calculate z-values based on tables. So again, our formula is going to be that our confidence interval is going to be our mean value plus and minus our z, our confidence interval, multiplied by the sample standard deviation divided by the square root of n. So over here, if we have that n is equal to 15, then our confidence interval is going to be, as it says right there, negative 0.33 plus and minus 1.96. That's my z value, multiplied by 2.46, that's my sample standard deviation, divided by the square root of 15. Again, 15 is my n for this sample. So we get negative 0.33 plus minus 1.24. And then we get our confidence interval for 95% for n equals 15 being equal to from negative 1.57 to 0.91. Okay, now this right here leads itself to pretty simple calculations, and what I actually did is that we could actually do this in Excel. Okay, so right here what we're dealing with is, let's see how this looks in the screen. Okay, so basically what we have over here is that we have the information that's given to us. Okay, and we could set this up on a screen fairly easily. So again, over here we're going to use the same z value, 1.96. My x bar is going to be the same, the mean, negative 0.33. My sample standard deviation is going to be the same, 2.46. The only thing that's going to change over here is my sample number, 15. Now we're going to do this calculation. So it's basically going to be z multiplied by s divided by the square root of n. And you take a look at this. The way this is presented is a little bit different, you know, but it's still the same mathematics, except that we're doing this in Excel. Okay, and so basically we find out, remember, don't get intimidated by all of this. This is the same thing as we did over here, except that it's just a lot faster. So now the only thing that we could really see is that as n increases, this value of z decreases. And that makes sense, because it means as we have more of a sample size, the uncertainty on our value decreases. So over here, again, all that we're doing over here is that we're taking, let's see, we're taking our mean number and we're subtracting it by this difference, and over here we're adding to that difference. Okay, and in that case we could develop a table that looks pretty much like this, going straight up and down. And again, the formula that we're using is that our confidence interval of 95% is going to be equal to the mean plus minus my z value at 95% multiplied by s divided by the square root of n. Okay, so what we did before was that we used our confidence interval based on a z value. Right now, really what we want to do is set up our confidence interval based on a t value. So over here we have a t value, and that t value is going to depend on my confidence level, again 95%. But over here we're going to have another variable, which is my sample size. And from here we get something called degrees of freedom. But everything else is going to be the same. So it's going to be s, the sample standard deviation, divided by the square root of n. Okay, now the main thing here is, how do you get this t? Well, this t is going to be based on 95% confidence level and my sample size. So now if we take a look over here, we're going to do the same thing but with a t value for a smaller samples. Usually this is, you would use the t value instead of z based on what they tell you, but I would say around 50 would be a good number. So if you have anything under 50, you would use a t value. But here we go. Here is the difference. My t value, as my sample number increases, my t value also decreases. And if you remember, all of the z value for 95% was 1.96. So we're going to get closer and closer to 1.96 as my sample number increases. So again, the same thing over here, and we're basically just using instead of z, we're using the t value, and we're going from a lower end to an upper end. And the only thing is, this is just more statistics. Supposedly the number is going to be a little bit better. And again, it's going to be a confidence level of 95%. So it's still going to be the mean plus and minus my t value for 95%, standard deviation, sample standard deviation divided by the number of samples. Okay, there's definitely a lot to talk about the t. There's things called degrees of freedom based on your sample size. It's just n-1, very easy. And then there's something else called the alpha, which is based on the confidence level that you're requiring. Again, all of this is relatively simple. Also, I did want to show you, for example, I get these t values based on a formula in Excel, and that's this one, TINV. My confidence is 95. I'm going to use 0.05, and now I'm going to use basically J8, which is 15 minus 1, and there it is, J8 minus 1. And if I keep going all the way down, we see that the formula is still the same. Okay, so again, if you're taking a basic class, you might not, and you're not talking about t values yet, then you just go ahead and use the z value. It's going to give you a very close approximation. If not, if you're using the t values, then you would go ahead and use the t values. Okay, thank you very much. Please let me know if you have any questions, and if you have any specific homework questions, please send them to me, and I'll do my best to answer them. Thank you.